Welcome to the second simulation tutorial of GTAP 101. My name is Zeynep Akgül. In this second tutorial, we are going to explore RunGTAP further and talk about the tab pages in more detail. We will learn how to define and run a model experiment. Then we will talk about the model results. First, let's take a closer look at RunGTAP's tab notebook interface. Now the first tab is the title page. The second tab, RunGTAP, contains general information about the software and the GTAP model. You are familiar with the version tab from the previous tutorial. Just remember that it contains information about the current data aggregation. The remaining tabs here are related to the experiment we would like to run. Our focus will be on these tabs in this tutorial. There are 4 items that go into an experiment file. We need a type of closure, a shock, a solution method, and the parameter file. It is a very good practice to follow your checklist before you define and run an experiment. We are going to talk about each of these items in this tutorial by working on a particular experiment where we shock the numerior of the model. Actually, the numerior experiment is automatically provided in the GTAP software, but I will show you how to set it up as an illustration of how to build an experiment. The version we will use today is the US 3x3 database, which we have created in the first tutorial. Let's get started right away and load up this particular version. Go to the version submenu and from the drop-down menu, select Change. When you installed RunGTAP, it came with some predefined versions. So what we see here is a list of those predefined model versions. Since we have created our US 3x3 version of the database before, we can now find it in this list. So let's find it, select it, and click on OK. This will transfer us to the version tab, and we can see that RunGTAP successfully switched to the US 3x3 version. Now let's start defining our numerior shock experiment from scratch. The first thing we will do is to go check the closure. Let's move on to the Closure tab to see what it entails. A closure defines which variables are exogenous and which variables are endogenous in the model. Here on the Closure tab, you see this text box where we have some statements. The exogenous variables are the ones listed under where it says exogenous. And the rest of the variables, which are not listed, are endogenous. This is stated here as the rest endogenous command. This particular closure is the standard general equilibrium closure in the GTAP model. What we want is to make sure that there is no closure rule change left here from a previous experiment. If there is something below the rest endogenous statement, then we need to erase it and add statements based on the closure we need. For the numerior shock, we need the standard general equilibrium closure, so what we already have is good. Later in the course, we will work with different closures. So we check the closure. The second thing we will do is to go check the shocks. The Shocks tab is where the variable to shock is defined and set. Here it is a very good practice to go ahead and click on the Clear the Shocks list. This will remove the shock that belonged to a previous experiment, and this will later save you from the trouble of having irrelevant shocks in your experiment. So let's do that. Now that we have a clear start, we need to define our own shock. In this experiment, the usual numerior for GTAP is increased by 10%. The usual numerior variable in this model is the world price index of primary factors, and it is denoted by pFactWorld. Since it is selected as the model numerior, it is similar to a price level variable. By changing this variable by 10%, we change all prices in the model by 10%. So let's go to the drop-down box here and find pFactWorld and select it. Here, we are also given the description of the numerior, world price index of primary factors. And a new edit box entitled percentage change shock will appear. So click in this and type in 10. Then click on the Add to the Shock List button. This will automatically create a shock statement here. So there we have the shock set now. Let's remember the checklist. We have the closure, we have the shock set. Now what we need is the parameter file and the solution method. Let's go to the Solve tab for those. Here we will check whether the parameter file loaded up is the one we want. So if we click on Change here, we will see a list of predefined parameter files. Among this list, what we need is the default parameter file for this experiment. So select Default and click on OK. The default parameter file is loaded up. The last thing we need to set is the solution method. From the first change button, we can select which method we want RunGTAP to use in solving the model. And from this window, we see that RunGTAP offers a variety of different solution methods. In this course, we will either use the Johansson, which is a single-step solution method, or the Greg, which is a multi-step solution method. For this particular case, what we need is the Johansson method. So make sure that it is selected and click on OK. Now we are all set to run the experiment. It is always a good practice to save our experiment for later in case we might want to go back to it. So go to the experiment description box here and type in GTAP 101 numeric shock. And let's go ahead and click on this button here where it says Save Experiment. From this same experiment, we can enter a name for the file and add more to our description. Let's call it GTAP 101. And I'm happy with the description, so let's click on OK. If later you want to redo this experiment, you can click on the Load Experiment button here and select this particular experiment. Now we are all set to actually solve the model and look at some results. Let's go ahead and click on Solve. And for this particular problem, this takes only a few seconds. Then you will get this information window saying that the solution is generated in the results page. Just click on OK. RunGTAP offers many different ways to look at the output. One of these options is to go to the Results tab. On the Results tab, you will see the Contents page listing many of the variables in the model. The first column has the variable names, the second column lists the dimension of the variables, and the last column has the descriptions associated with the variable in question. In the first column, you will notice that some variables are lowercase and some of them are uppercase. Lowercase in GTAP means that the variable is expressed in terms of percentage change. Uppercase means that variables are expressed in value terms. Let's dig deeper to see what it means. The experiment we run today is a 10% increase in the numeric. So what do we expect to find in the results? Since all the prices in the model are relative to the numeric, a 10% increase in the numeric means that all prices in the model should increase by 10%. So we expect to see a price change of 10%. And what about output changes? We have a model that is homogeneous of degree 0 in prices. When we say demand is homogeneous of degree 0, it means that for any changes in the independent variables, the dependent variable does not change. So a 10% increase in all prices means that there is no change in relative prices. And when relative prices do not change, there is no change in quantities. So what we expect is the output to change by 0%. Now let's look at the results for market prices and output to check whether our expectations are realized or not. The market price is denoted as PM in GTAP. Let's scroll down to find it in this list. So here we have it, market price of commodity I in region R. Just double-click on this corresponding row. And here we see the percentage change in the market price of factor endowments, land, labor, capital, and market price of produced goods, agriculture, manufacturing, services, and capital goods. In the two regions we have in this model, USA and rest of the world. As you can see, the changes are all 10%. And a numeric shock is equivalent to a 10% increase in all prices. Let's see what happened to the output. For that, we need to return to the main list. There are two ways to do this. We can hit the Contents button here, or we can double-click on this page. Let's hit the Contents button. So what we are looking for is the output variable, which is a quantity variable and denoted as QO. So scroll down to find QO and double-click on it. Here we see that the top three rows are in red. This is because the factor endowments are exogenous, so there is no change in the quantity of land, labor, and capital. The remaining variables are shown in black, and they are the endogenous percentage changes. As you can see, they are also all 0. This is because the model is 0-degree homogeneous in prices. Therefore, a 10% increase in the numeric does not lead to a percentage change in quantities. This shows us that our expectations are realized. And this test for homogeneity of demand gives us information about the model behavior, so it is an important check. This is all for the second tutorial. Now we are ready to move on to the next stage and work with different experiments. So see you in the next tutorial.